Past the orbit of Saturn, the Sun stops being a source of warmth and becomes just another star. Out here, light is rationed. The worlds that drift through this region get so little of it that high noon would look to your eyes like the last gray minute of dusk. For most of human history, they were barely points of light, and the single probe we sent through decades ago handed us only a few fleeting postcards before vanishing into the black. Then a new kind of eye opened above the Earth. The James Webb Space Telescope was built to stare into the deep past of the universe, but turned toward the frozen outer planets, it has done something stranger. Seeing in infrared, the language of heat, it has not simply taken prettier pictures, it has overturned what those worlds even are. Places we had written off as dead and finished turned out to be doing things no one expected. 3 worlds in particular have refused to behave. One spins on its side, locked in a cold deeper than anywhere else around the sun. Another is drowned in darkness, yet screams with the fastest winds ever recorded. And the last, barely larger than our own moon, is quietly bleeding its own sky onto the surface of its companion. What follows is what Webb found at the cold limits of our system, and why some of it is genuinely hard to sit with. Start with the world that looks the most harmless and turns out to be the most disquieting. When the only spacecraft to tour the outer planet swept past Uranus in the 1980s, it sent home an image that became something of a punchline among astronomers. A smooth, pale blue sphere with no clouds, no storms, nothing. A planet that looked switched off. For decades, that was the official portrait. Uranus was the dull one, a featureless ball of cold gas rolling along at the far rim of the Sun's reach, about 1.8 billion miles out. That pale blue, by the way, is methane. The gas wrapped around Uranus drinks in the red part of sunlight and throws back the blue, which is why our eyes register a calm, uniform aquamarine. Visible light flatters it into looking serene. The serenity is a quirk of which colors happen to bounce off it, not a true reading of the planet. Change the wavelength and the whole disguise falls apart. That portrait stuck because we had nothing to replace it with. The probe that took it was on a once-in-a-lifetime tour of the giant planets, and after that flyby, no spacecraft ever returned. For more than 30 years, those few fading frames were the entire close-up record of Uranus. What finally replaced them did not come from a new mission. It came from a telescope parked a million miles from Earth, with a mirror more than 21 feet across, sharp enough to read a world we had all but given up. Then Webb looked, and the dull planet vanished. In infrared light, the same world lit up with structure. A bright, swirling cap sat over one pole, glowing like a frozen eye. Storms flickered along its edges, encircling the whole planet were its rings, standing upright rather than lying flat, including the faintest and most elusive of them, a delicate band so dim that scarcely anything had caught it. The placid marble had been an illusion all along. Underneath the 7th planet was weather, seasons, and a quiet violence our older instruments simply could not register. The rings alone are a story. Uranus is circled by 13 known rings, far darker and narrower than the bright bands of Saturn, and Webb traced them with a clarity no telescope had managed from this distance. Scattered among them, the observatory picked out moon after moon, more than 24 in all, small icy bodies shrinking like pale beads against the dark. If we send a craft to study the planet up close, those faint rings become a hazard, a field of debris a spacecraft would need to thread without being torn apart. What makes this world genuinely alien is the way it sits. Every other planet spins more or less upright while circling the sun, like tops on a table. Uranus lies on its side, tipped over at an angle of about 98 degrees, rolling along its orbit like a ball knocked off a shelf. The leading idea is that an enormous body struck it in the distant past, a strike violent enough to tip an entire planet and leave the planet turning the wrong way for the rest of time. That single, ancient collision still shapes nearly everything about this world. Because it lies on its side, Uranus has the most extreme seasons anywhere we know. As it crawls along its long orbit, first one pole and then the other points nearly straight at the faraway sun. Each pole spends roughly 21 years bathed in faint, unbroken daylight, then drops into a night that also lasts about 21 years. Whole decades of darkness, then decades of dim glow, cycling on a clock far longer than a human life. The bright cap Webb captured is the pole now turning to face the sun, slowly waking after its long winter. That cap is one of the things astronomers most want to watch. As the planet nears its next solstice, the pole will turn to point nearly straight at the sun, giving us the clearest view of it we have had. The cap brightens and shifts as the light hits it, and tracking those changes over the coming years should help untangle what is seasonal from what is simply weather. For the first time, we get to watch a full alien season turn on a world tipped completely onto its side. Its strangeness runs deeper than its tilt. Uranus has a magnetic field that is widely lopsided, tipped far from the planet's spin axis and shoved off-center, so the whole magnetic environment wobbles chaotically as the world turns. And in the crushing pressures deep inside both ice giants, scientists suspect something hard to believe. Carbon gets squeezed so hard that it forms diamonds, which then sink through the interior like a slow rain. Whether or not that picture is exactly right, it captures how strange the insides of these worlds truly are. From one of its moons, the view would be unlike anything in our sky. For years on end, the sun would hang nearly motionless over a single pole, a small, fierce point that never sets, while the opposite half of the planet stays drowned in a darkness that does not lift for 2 decades. Seasons measured in human lifetimes, a sun that refuses to move, and a pale ring giant lying on its back across the sky. It's a place that breaks the rhythms we take for granted, day and night, summer and winter, all of it stretched and tilted past recognition. Then there is the cold, and this is where the planet stops being merely odd. It holds the record for the lowest temperature ever measured on any planet we know, reading of about minus 371 degrees Fahrenheit. That's colder than Neptune, which orbits nearly 1 million times farther out, and that fact by itself is a real puzzle. A world has no business being colder than the planets beyond it. The reason seems to lie deep inside. Most giant planets glow faintly with their own internal heat, leftover warmth from their birth that leaks slowly into space across billions of years. Uranus barely does. It gives off barely any heat of its own, as though its inner furnace had gone cold or been smothered. Some researchers suspect the same catastrophic impact that knocked it sideways also let much of its internal heat escape, leaving behind a planet that is, in a sense, freezing from the heart outward, a giant quietly running out of warmth at the rim of the dark. Numbers that low are hard to feel, so think of it less as cold and more as a stillness so total that ordinary matter changes its behavior. At those temperatures, gases we breathe would freeze solid. Whatever weather exists plays out in a thin, frigid skin of methane and hydrogen wrapped over an enormous slushy interior of water, ammonia, and ice. That mixture is why astronomers reach for a different label for this planet and its twin. Not gas giants like Jupiter, but ice giants, a class all their own. There's even a practical reason scientists keep coming back. Across the galaxy, the most common planets found circling other stars are roughly this size, neither small rocky worlds like ours nor vast gas giants. Uranus is the nearest example of that in-between kind of world. Learning to read its frozen, tilted weather is, in a strange way, rehearsal for understanding planets light years off what we will likely never reach. The harmless blue marble was hiding all of this in plain sight, simply because we lacked the eyes to see it. Hold on to that picture of a world frozen on its side, because it is about to look almost gentle. The next planet out makes Uranus seem calm. Before we travel there, a question worth sitting with, and the comments are the place for it. Of these 3 frozen worlds out at the cold limit of everything, which one truly unsettles you the most? Keep your answer in mind. By the time we reach the last one, it may have changed. What comes next is a world soaked in darkness that somehow cannot stop moving. Neptune is the last of the major planets, the final large world before the solar system frays into scattered ice and empty space. It orbits more than 30 times farther from the Sun than Earth, roughly 2.8 billion miles out, in a region so dim that noon there would feel like deep twilight. Sunlight at Neptune is roughly 900 times weaker than the light we stand in every day. By any honest measure, it is a world that lives in the dark. Neptune has unsettled people since before anyone laid eyes on it. The planet was first found not by looking, but by mathematics. In the 1840s, astronomers noticed Uranus drifting slightly off its predicted path, as if an unseen mass were tugging at it, and they calculated where that hidden world had to be. They aimed a telescope at the spot, and there the planet sat, a world discovered as a disturbance in the dark before anyone observed it, which is a fitting introduction to a world that keeps defying expectation. For more than 30 years, our only close look came from that single passing probe in 1989, which glimpsed a set of faint rings before racing on into the void. Nothing returned. The rings faded back into rumor. Then Webb fixed on Neptune and brought them back, sharper than they had appeared in 3 decades. Thin, bright bands and fainter sheets of dust ringed a planet that, in infrared, does not look blue at all. Methane in its air swallows the very light Webb sees by, so the globe itself goes dark while its high clouds blaze like scattered embers. In ordinary light, Neptune is the deep, vivid blue of the textbooks, painted by the same methane that colors Uranus. Through Webb, that blue disappears entirely. The planet turns into a dim, ghostly sphere, streaked with bright patches, the patches being clouds of methane ice riding high above the gloom, catching what scant light reaches them. It is the same world shown in a language our eyes cannot read, and in that language, it looks haunted. Then there is the thing in the corner of the image that outshines the planet entirely. It is not a star. It's Triton, Neptune's largest moon, blazing far brighter than the world it circles. Triton is sheathed in a frozen skin of nitrogen so reflective that it throws back most of the feeble sunlight reaching it, glowing like a pale lantern. Stranger still, it travels backward, going the wrong way around its planet. That single fact gives away its past. Triton did not form here. It was a wanderer from the deep belt of frozen bodies beyond Neptune, seized long ago by the planet's gravity and dragged into an orbit against the grain. A stolen moon still circling the wrong way. Triton carries its own quiet menace. Despite the brutal cold, it is not frozen solid and lifeless. The lone probe that passed it caught plumes erupting from the surface, dark geysers venting into the thin air, a sign of activity on a moon that should be utterly dead. And its backward orbit is slowly decaying. Over the deep future, Triton is spiraling inward, and one distant day, Neptune's gravity will rip it apart into a brilliant ring. The stolen moon is very gradually falling. Now, Neptune turns frightening. A world this far from the sun, this starved of light and heat, ought to be sluggish and quiet. Instead, it owns the fastest winds anywhere in the solar system. Gusts there tear across the planet at more than 1,200 miles per hour, faster than the speed of sound, shredding clouds of frozen methane across the globe. For scale, the most violent winds Earth can produce, deep inside our worst storms, top out near 250 miles per hour. Neptune's ordinary weather would flatten anything our planet has managed. It's hard to overstate how wrong that should be. Wind needs energy, and energy out here barely exists. The sun is a faint spark, far too weak to whip an atmosphere into supersonic motion. On Earth, our weather is the sun's doing, heat stirring the air. Neptune builds the most ferocious weather of any planet on a starvation ration of sunlight. That power has to be coming from somewhere else. The obvious question is what drives that fury? The answer is buried in the planet, and it is a mystery scientists still cannot fully crack. Neptune gives off about 2.6 times more heat than it receives from the sun. Something deep inside it is hot, far hotter than its frozen face suggests, pumping energy upward and powering those supersonic storms from below. Its near twin, Uranus, does the opposite, leaking hardly any warmth at all. Two worlds, born side by side, nearly identical in size, and yet one has gone cold while the other still burns at its core. Nobody is certain why. Neptune is lopsided in its own way. Like Uranus, it carries a magnetic field tilted steeply from its axis and pushed off-center, so its magnetic shell lurches and flips through each rotation rather than holding steady the way Earth's does. Even the invisible architecture of these worlds is crooked and restless. None of it lined up the tidy way our own planet is. The closer we look, the less either ice giant resembles a simple, settled sphere. Webb and earlier instruments have watched colossal storms boil up on Neptune and then disappear. One large vortex spotted decades ago was wide enough to swallow the entire Earth, and within a few years it had simply gone, replaced by another somewhere else on the globe. These are not gentle seasonal shifts. They are continent-sized storms appearing and dying in the dark, fed by a furnace we cannot see, on a world where the sun is barely a bright star. The telescope even traced a thin line of brightness circling Neptune's equator, the signature of the great churning circulation that drives all of it. It's worth pausing on what darkness like this means. On Neptune, the sun is just a piercing point of light, brighter than the other stars but offering almost no warmth. There is no day in any sense we would recognize, only a long blue-black gloom lit by a distant spark. And through that gloom, the winds keep screaming. So put the full scene together. A planet adrift at the cold limit of the sun's family, cloaked in dark, ringed in faint dust, shadowed by a stolen moon that outshines it, and lashed by the most violent winds we know of, all powered by a heat source no one can explain. Neptune is proof the distance from the sun does not buy peace. That leaves the smallest and most remote of the three, a world so far out that for a long time it was scarcely more than a rumor with a name. Pluto orbits along the ragged outer fringe of the solar system, on average some 3.7 billion miles from the sun, out where our star is just one more cold point of light. Pluto is tiny, smaller than our own moon, and in 2006 it was formally stripped of its rank as the 9th planet and reclassified as a dwarf, one of countless icy bodies drifting in the dark belt beyond Neptune. For a while that demotion made it feel like a footnote. Pluto is anything but. The first real look arrived from a probe that spent close to a decade crossing the solar system before it reached its target. What it found stunned everyone who had braced for a dead, cratered rock. Pluto has mountains of frozen water ice standing miles high, broad, smooth plains of nitrogen ice, and a thin, hazy atmosphere stretched into delicate blue layers. Most telling of all, parts of its surface are young, smooth, and free of craters, which means something is actively resurfacing them. On a world this cold at this distance, the last thing anyone expected to find was a geology still in progress. The arrival itself was a kind of miracle of patience. The probe had been launched while Pluto was still officially the 9th planet, and by the time its streak passed years later, Pluto had already been demoted. It had one chance, a single high-speed flyby. No orbit, no second pass. In a few hours, it gathered more about this world than all of history combined, then fell silent and kept going. Nearly everything we thought we knew about Pluto was rewritten in that single afternoon out past Neptune. The centerpiece is a vast, pale plain shaped roughly like a heart, a basin filled with frozen nitrogen that behaves like a slow churning glacier. Heat from deep within nudges the ice into enormous sluggish cells that turn over across ages, smoothing away any crater that tries to form. It's a sea of frozen air, gently boiling in ultra-slow motion out in the deep cold. Nothing about Pluto's distance or its temperature says that should be possible, and yet there it is, written across the surface. That activity is the unsettling part. Across Pluto's surface, glaciers of frozen nitrogen flow and churn, slowly cycling between the ground and the sky as the dwarf world tilts through its long seasons. Ices vaporize in one place and freeze out in another, reshaping the landscape over time. This is a body at the very limit of the sun's influence, where temperatures fall to around minus 375 degrees Fahrenheit, and yet it refuses to sit still. It behaves less like a dead rock and more like a slow, frozen engine, grinding away in near total darkness where nothing should have the energy to move at all. This is where Webb adds a chapter of its own, Studying Pluto in infrared, researchers confirmed something genuinely strange about that delicate haze. The thin layers of smog wrapped around the dwarf planet are not just a byproduct of its weather. They actually govern its climate, soaking up and shedding heat in a way that helps set the temperature of the whole world. Pluto, in effect, wears a haze that runs the planet's thermostat, a mechanism unlike anything on the planets closer to the Sun. That haze has a familiar recipe. It forms when sunlight breaks apart the methane and nitrogen in Pluto's air, and the fragments knit themselves into a fine, layered smog, the same basic chemistry that shrouds Saturn's giant moon Titan. Seeing the process play out on a world this small and this far suggests it may be common at the solar system's edge, quietly shaping the climates of distant bodies we have barely begun to map. A thin veil of haze, it turns out, can run an entire world. Then comes the detail that feels like a ghost story. Pluto's not alone out there. It has a large companion, a moon named Charon, about 750 miles across, and so big relative to Pluto that the two orbit a point in empty space between them, locked face to face forever. Webb's data supports a quietly eerie picture. Material from Pluto's own atmosphere is escaping, drifting across the gap, and settling onto the poles of Charon, slowly staining them a dark reddish color. One world is very literally bleeding its sky onto another. As far as we know, nothing else in the solar system behaves this way. Charon is not the only thing out there with Pluto. 4 smaller moons circle the pair, small splinters of ice with names like Nix and Hydra, and they do something faintly comic and slightly unnerving. They tumble. Rather than rotating smoothly, they pitch and roll chaotically through space, their spin never settling, yanked between the shift-pull of Pluto and Charon. A whole miniature system at the far fringe of the Sun's reach, wobbling in the dark, none of it behaving the way moons are supposed to. Webb went further and read the surface of Charon itself, picking out chemistry no one had confirmed before. Frozen carbon dioxide sits on its surface, very likely primordial, a leftover from the raw material that built both Pluto and its moon at the dawn of the solar system, exposed where impacts have punched through the crust. Alongside it, the telescope found hydrogen peroxide, forged as radiation and particles from deep space slowly tear apart the water ice on Charon's surface. These frozen worlds are not just sitting there. They are being worked on ceaselessly by the harsh emptiness around them, and they carry a chemical memory of how they were born. It reframes the whole outer dark. We tend to assume that far enough from the Sun, worlds simply stop, sealed in permanent stillness. Pluto says otherwise. So little energy reaches the dwarf planet that its surface ought to be inert, and instead it flows, breathes, and feeds its moon. If a body this small and this distant can stay this alive, that raises an uncomfortable question about how many other quiet, frozen worlds out there are secretly doing the same. This footnote turns out to be one of the most active and intimate pairs of worlds we have found. Step back from 3 of them, and a pattern emerges that humbles you in a specific way. For most of history, we pictured the outer solar system as a frozen wasteland. A few dead worlds and a scattering of ice marked the lonely border of the Sun's territory. Yet one of them lies tipped on its side, knocked there by an ancient blow and freezing from within, while a second is drowned in darkness and screams with supersonic winds driven by a hidden furnace. And the smallest, no bigger than a moon, still flows and breathes and bleeds its sky onto its partner. Not one of the 3 is dead. They were only waiting for an eye sharp enough to catch them in the act. That is the quietly unsettling lesson underneath all of it. The things we call empty, lifeless, finished, so often turn out to be none of those. And the only reason for that belief was that we could not see clearly. The very telescope built to look back toward the birth of the universe keeps reminding us how little we grasp of our own backyard. There is a fitting symmetry in that. We built an instrument to change the first light of creation, and along the way it keeps tripping over secrets a few light hours from home on worlds we had already filed away. The frontier was never only out among the galaxies. A good deal of it was sitting in our own neighborhood the whole time, frozen, patient, and far from finished. It also resets our sense of what is normal. We are a single warm planet, close to the fire, and we assume that warmth and light are the natural state of things. Out where these worlds drift, the opposite holds. Cold, dark, and distance are the rule across nearly the entire solar system, and our small bright world is the rare exception, a thin band of comfort circling one ordinary star. Webb is slowly mapping that vast frozen majority, one impossible discovery at a time, and every pass seems to find another world that was never as dead as we assumed. And the deeper Webb looks, the louder one question grows. If these are the worlds at the outer boundary of our own system, what waits in the dark between the stars? And could anything we have ever built actually reach it? We followed that exact thread in our video on whether the Voyager probes will ever reach Alpha Centauri, the nearest star to our own. If the distant solar system pulled you in, that is where to go next. Stay insanely curious.